Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 3 for this week. And I bet you thought I wasn't going to keep my promise of getting this out on Sunday. And I know it's late. Do you know the difference between a perfect person and a perfectionist? A perfect person, as far as I know, there's only been one of those in recorded history, is somebody who's actually perfect, and nobody else can live up to that, least of all me. A perfectionist is somebody who spends an inordinate amount of time trying to be perfect when he knows the entire time that he can't do that. That is me. I actually have spent 9 hours on this presentation and I'm still not real happy with it, but it's the best I can do, and I wanted to get it out before the date changed because I told you I would. So, all right, so we are going to talk, and there was actually a report from the British Met Office talking about a sudden stratospheric warming event, which is basically a breakdown of the polar vortex, and that this could lead to, is the operative word, lead to some extreme weather by mid to late March, okay? This does not always work out, okay? Sometimes it does, a lot of times it doesn't, but I thought it would be interesting to talk about it nonetheless. So I know you've heard about the polar vortex, and most of the time that's being referred to in the troposphere, but there's also a polar vortex in the stratosphere, and the two talk to each other, and it can end up having a significant impact on the weather in the troposphere where we live and where all the sensible weather goes on. So that's what we're going to talk about today. So let's go on ahead here and get started. And so we're going to talk about the vertical structure of the atmosphere. Now there are several layers. We're just going to focus on 2 of them today. Here's the ground down here. The troposphere on average extends from maybe about the ground to about 10 kilometers above the ground, or actually above sea level. And then the stratosphere is much, much less dense, but it extends all the way from about 10 kilometers up to 50 kilometers, okay? So those are the 2 levels, or 2 layers, if you will, of the atmosphere that we're going to focus on today. All right, so now let's take a more detailed look here. And I'm going to compare February 27th with March 2nd. Now, February 27th, it hit 77 at the RDU airport. Today, it only hit 51. So clearly, the atmosphere was quite a bit colder today than it was on the 27th. And so let's take a look. And you remember how we talked about thickness, where if you have a constant pressure surface, that the distance between 2 constant pressure surfaces, when it's larger, the air between them is warm or warmer, and when it's smaller, the air between the 2 levels is colder. So I picked out 1,000 millibars, 250 millibars, which is roughly where the top of the troposphere is, or at least was on these 2 days, and then 10 millibars, okay? And that's up at about, like 30,000 meters, which would be 30 kilometers. Yes, all right. So that's way, way up there. Okay, so here's the stratosphere, here's the troposphere. What I want you to notice here is that the distance between 10 millibars and 250 millibars actually increased, okay? The distance between these 2 constant pressure surfaces got bigger, and so that means the temperature in that layer got warmer. And down here in the troposphere, the bottom layer, the 1,000 millibar surface, actually got higher, and this boundary right here got lower, and so the distance between these 2 constant pressure surfaces was smaller, and thus the air colder. So the stratosphere warmed, the troposphere cooled, okay? And so a lot of times when you see the stratosphere warm, there will be a compensating effect in the troposphere where it will actually be colder, okay? All right, so now let's move on. If I can get the picture to change here. There we go. So again, this distance got bigger, this distance got smaller. Okay, so the stratosphere warms and the troposphere cools. Now, how the polar vortex actually forms. So here we have our trusty Earth with its axis, and of course it's tilted at 23.5 degrees. Now, at that point in time, on December 20th or 21st, the sun's rays are not hitting the North Pole at all, okay? They have 6 months of continuous darkness up there. And so the air in the stratosphere gets very, very cold, and a vortex forms as a result of the fact that it's completely dark and they're not getting any sunlight for 6 months up there. So the air gets very, very cold in the stratosphere, and I couldn't make this rotate the way I wanted to, but it's a counterclockwise rotation like that, like a vortex, okay? All right, so that's how the whole process gets going. So here is an animation of the winds around the stratospheric vortex, polar vortex, at about 10 millibars, okay? And the red colors indicate where the winds are really, really strong. And notice how they go all the way around. Now, this is sort of an elongated vortex in here, but still you have very strong winds all the way around it, which means you have a lot of temperature contrast from the middle of the vortex to the outer edges and the mid latitudes, okay? And when it's completely encircled like this, that basically keeps all the really cold air bottled up in the Arctic regions, okay? It doesn't allow it to spill out. Now, what is forecast to happen, and I'm going to try to put this in motion here. Let's see if, okay, so you can see that all the way encircling the vortex. Now, I think, I'm going to play it safe here. I'm going to go over here and start this animation. There we go. Okay. So watch this here. And this is a 32-second animation, so it's going to take a little bit of time to evolve. We still have the winds around the vortex pretty strong, so no Arctic outbreaks. But then we start to see a sudden strengthening of it here and almost a new vortex forming. And this vortex gets completely destroyed, okay? It completely opens up, and there's basically nothing left of it. And even this one, with time, begins to weaken so that we don't have strong winds all the way around it. So the argument here is that when the polar vortex breaks down, then that reduces the impact of it keeping all the cold air bottled up in Canada because it has all those strong winds going all the way around it. When it breaks down, that basically opens the floodgates, at least potentially, for all of that cold Arctic air to sink southward into North America, or at least somewhere around the globe in the mid-latitudes. It could be Europe, it could be Asia, or whatever, but basically that's the argument. This is a relatively recent area of research, okay? It is not foolproof, it does not work every time, so anybody that tells you that, oh, there's a sudden stratospheric warming and all heck's going to break loose in the middle and late part of March, that's not a guarantee at all, okay? It's something that happens sometimes, but not all times. But I still thought it would be interesting to basically talk about it, how it forms, and what can happen when these vortexes break down and allow the colder air to sink farther south into the mid-latitudes. So we'll see what happens. It'll be interesting to watch. But again, nothing foolproof about this at all. All right. So that is bonus weather video number 3 for last week. Bonus weather video number 1 for this coming week will be coming up tomorrow or today, depending on when you watch this. And the next daily update, of course, coming up tomorrow as well. And there is a chance, and it's just a chance right now, that Wednesday could be a severe weather day. There's going to be a very vigorous upper level disturbance coming in from the west. The question is, will the atmosphere become unstable enough for that disturbance to make use of and produce strong to severe thunderstorms? But that is something we'll be watching, and I'll have more on that tomorrow. Okay, folks, you have a great rest of your Sunday evening, or in the case of watching it tomorrow, a great Monday, and we'll talk to you either tomorrow or later today. You all take care. We'll talk to you soon. See you later.